Hello, my name is Ben McGahee with McGahee Mathematics, and today's video lesson is on prime numbers. So prime numbers are special numbers, that you see in nature, in life. Basically, they're everywhere. But let's go over what the definition of a prime number is. A prime number is basically any positive number that's divisible by 1 and itself. So the first prime number would be 2. And then next prime number would be 3. And then you have 5 and 7 and 11 and so forth. So notice that these numbers are only divisible by 1 in itself. So 2 is just 2 times 1, and then 3 is 3 times 1, and 5 is 5 times 1, 7 is 7 times 1, and then 11 is just 11 times 1. So the only factors are just 1 in itself. A number that is not prime is called composite. So let's write that down, composite. So an example of a composite number would be like 8, because you can factor 8 as 2 times 4. So its factors are not divisible by 1 in itself. And 2 and 4 and also 8 and 1 are also factors for 8. Another example would be 20. So you could factor that as 2 times 10 is 20. And then you can factor 10 as 2 times 5. So you can see that 20 is not a prime number, because you can have other factors besides 1 and 20. You could have 2, you could have 5, and even 2 times 2, that's 4. 4 is also a factor of 20, and then also 10 is a factor of 20. So those are examples of composite numbers. So another thing that I want to show is how to write a composite number in the terms of its prime numbers, prime factorization. So let's say we want to factor the number 63. So if we factor 63, and we know from our times tables, we know that 9 times 7 is 63. So 9 and 7 our factors. We know that 7 is a prime number, so we just leave that alone. But we can factor 9 is 3 times 3. And 3 is also a prime number, so we can stop there. So we know that 63 is equal to, we take the numbers here at the bottom of the tree and multiply them together. So we have 3 times 3 times 7. And then this equals 3 times 3. If we write that, that is 3 to the second power, because we multiplied 3 2 times 7. So this would be the prime factorization for 63. 3 squared times 7. Okay, let us look at one more example. Let's say we have a bigger number to factor. Let's do like a 3-digit number. Let's do 145. So we want to find the prime factorization of 145. So we know that since the last digit here in the ones place, that's a 5, we know that this number is divisible by 5. So we know that 5 is a factor of 145. And then we can do some division to the side to do 5 into 145. So 5 goes into not 1, but it goes into 14 2 times. 2 times 5 is 10. Then we subtract 14 minus 10, it's a 4, and bring down to 5. And then 5 goes into 45 9 times. 5 times 9 is 45. That's 0. So we know that 29 is also a factor. So 5 is a prime number, and also 29 is also a prime number. So we know that 145 equals 5 times 29. Okay. Let's do one more, just to make sure that we understand how to find a prime factorization of the numbers. Okay, so let's do Let's do 2 16. 216. So we know that this is an even number, so we know it's divisible by 2. And then we could ask ourselves, is this also divisible by 3? And the way we can answer this question is to look at all the digits. We have 2, 1, and 6. So if we add those together, we get 2 plus 1 is 3, 3 plus 6 is 9. And we see that 9 is also divisible by 3. So we know that 216 is divisible by 3. So let's divide by 3. And then we'll do 3 into 216. So 3 doesn't go into 2, but goes into 21. That's 7 times. And 7 times 3 is 21. And we subtract. And just get 0, because 21 minus 21 is 0. Bring down the 6. And we know 3 goes into 6 2 times. 3 times 2 is 6. And then we get 0. So we know that we have 72. So 3 times 72 is 216. So we can also factor 72. We stop with 3 because that's a prime number. So 72 is composite because it's even. And we also see that that's divisible by 3 as well, because 7 plus 2 is 9. So let's divide by 3. So 3 into 72. 3 goes in 7 2 times. 2 times 3 is 6. Subtract 7 minus 6 is 1. Bring down the 2. 3 goes into 12 4 times. 4 times 3 is 12. And subtract, get 0. So you have 24. 3 times 24 is 72. And we also notice that 3 times 8 is 24 from our times tables. And then 8 we know is 2 times 4. And then we have 4 is 2 times 2. And then we can stop there. So we look at all the numbers at the end of the branches of our tree. We have 3, 3, 3. Then we have 2, 2, and 2. So 216 can be equal to, we have 3 times 3 times 3. 3 3s times 2 times 2 times 2. And so since we have 3 3s and 3 2s, we can multiply. We can write that a little simpler, as exponents. That would be 3 to the third power times 2 to the third power. And then that would be our prime factorization for 216. Okay, so this is the lesson on prime numbers. Again, my name is Ben McGahee, and I look forward to presenting you more lessons on math. Take care. Have a good day.